So today we'll be looking at the theory of continental drift. We spoke about it a little bit in class today and read about the different pieces of evidence to support the theory of continental drift. So this video is just going to serve as a recap, and you'll be doing an activity tomorrow to kind of piece it all together. So theory of continental drift is that at one point all Earth's land masses were joined together in what's called a supercontinent, and then they drifted to their present-day locations. So this huge supercontinent was actually called Pangaea, and it is believed to have formed around 250 million years ago. So if we look at the formation and the breaking up of Pangaea 200 million years ago, this is what we believed the supercontinent looks like. All the land masses were very close together. Some were joined together. So 130 million years ago, it started to break up. 70 million years ago to our present day. And there are three pieces of evidence for continental drift. One is the landforms themselves, fossils that are found on each continent, and of course the climate. At first, the theory was rejected because there could be no explanation as to the amount of force, the type of force that could move huge continents. We now know that that force was actually plate tectonics, which we'll learn about in the next section. We'll look at that later. So if we look at the landform evidence, we can see that some of the continents seem to fit together like a huge puzzle. We also are able to compare the coal fields in Europe and North America and see that they are actually the same, and there are matching mountain ranges in South America and Africa that would lead us to believe that these two were actually touching at one point. So if we look here, we would be able to have those matching mountain ranges because it was all one landmass. We also see the similarity in the coal fields that are found on places that were also together in the supercontinent, and that it's one huge puzzle piece that can be actually joined. Our next piece of evidence is with fossils. So there are land animals that are found on South America and Africa, which are separated by an ocean. These land animals couldn't have it wouldn't be physically possible for them to have swam over such a huge ocean to be present in both continents. They would have had to be together. Also, we find fossils of plants that are found in South America, Africa, Australia, India, and Antarctica, which would also lead us to believe, since plants cannot swim across a huge ocean, that they were actually all together at one point. So again, here are those land animals that are found. So if we look at Mesosaurus, for example, we see that Mesosaurus was found all throughout Pangaea. Okay. And again, this is the plant fossil that I was talking about that is found all distributed through the South America, Africa, India, Antarctica, and Australia. And plants do not swim last time I checked. Lastly, we have climate. Fossils of tropical plants are found in polar regions, which again leads us to believe that at one point it was all tropical climate, so it would have had to have been next to each other. Scratches in rock that are made by glaciers covering South America, Africa, Australia, and Antarctica, and there's also coal found in Antarctica. So there was a huge change in climate at one point. And we can see that with this diagram here. And that concludes our presentation on